burns nearly half a gallon of fuel every single minute, just to stand still. While the rest of the world relies on massive diesel engines, the US Army decided to put a literal jet engine inside a 63-ton steel box. It's called the Whispering Death. It is faster, quieter, and mechanically more complex than any of its rivals. But was this a stroke of engineering genius, or a logistical nightmare? Today, we dive deep into the mechanics of the AGT1500. The decision for the turbine was made during the Cold War. The US Army needed an engine that was ready for action instantly, even in extreme conditions. First, cold start capability. While a 1,500 horsepower diesel might need hours of preheating in the Arctic, the AGT1500 starts instantly at -22 degrees Fahrenheit. Second, multi-fuel capability. This turbine is completely omnivorous. It will swallow kerosene, diesel, or gasoline. This provides massive flexibility on a global battlefield. In the world of tanks, acceleration is a life insurance policy. The AGT1500 delivers a precise maximum torque of 2,765 pound-feet. To put that into perspective, that is more raw twisting force than 4 modern twin-turbo V8 supercars combined. This nominal force is what allows this beast, weighing up to 63 tons, to accelerate so explosively, hitting 20 miles per hour in less than 7 seconds. The engineering advantage becomes clear when compared to its biggest rival, the MTU diesel of the German Leopard 2. The AGT1500 is a masterpiece of compactness. At only 5.3 feet long, it is nearly 3 feet shorter than the massive V12 block of the Leopard. Furthermore, the turbine engine itself weighs only about 2,500 pounds. Even with its massive transmission bolted on, it creates a propulsion package that is significantly lighter and more compact than the German powerhouse. This saved space allowed for a lower profile and more room for advanced armor. But the ultimate mechanical trump card is field maintenance. The entire turbine is built as a unified power pack. In combat conditions, a trained crew can crane out the entire engine and replace it in less than 30 minutes. However, this tactical advantage comes at a staggering financial and logistical cost. Manufacturing a high-precision jet turbine is vastly more expensive than building a standard diesel engine. And the maintenance is a non-stop money pit. Dust and sand can easily destroy the turbine blades, requiring highly specialized technicians. And then there is the fuel consumption. The Abrams carries about 500 gallons of fuel. On the road, it consumes roughly 1.7 gallons per mile. In heavy terrain, that spikes to over 4 gallons. But the real nightmare is idling. In standard idle, it burns 10 gallons per hour. But in tactical idle, keeping the turbine revved up for instant combat readiness, it burns a staggering 29 gallons per hour. Think about that. Every 60 seconds on the battlefield, this machine vaporizes a massive amount of fuel without moving a single inch. To make matters worse, the turbine blasts out exhaust gases at up to 1,300 degrees Fahrenheit. This creates a massive thermal signature for enemy sensors and makes it completely impossible for friendly infantry to seek cover directly behind the tank. The turbine is a weapon built for raw power, not economy. But if you think this American jet tank is crazy, wait until you see how the German Leopard 2 uses a completely different mechanical masterpiece to solve the exact same problem. That video drops next Sunday. Make sure you're subscribed so you don't miss it. I'll see you there.